We're going to talk a little bit about color light output.
Color light output is a new industry standard for the measurement of projector light output. And my name is Kral Lang. I'm from a company called Lumita, which is a color science consulting company, and I've worked with almost 50 different companies in the development of the color light output metric. So I'm going to start out this presentation. I'm going to talk about a little bit of the history of light output. So a lot of you are familiar with the term ANSI lumens. Or just ISE light output, which is the current standard for white light output. And the ANSI lumen standard, which is identical to the ISE standard, the international standard for white light output, was originally created in the 1990s when this was the only projector we had. And so basically all that we needed to do was measure light on that projector, because the projector itself had three guns, red, green, and blue. They were CRTs and a big lens in front of them, and they shined at the screen, mixing red, green, and blue together to create the white light. So all the light output of the projector could be measured by simply putting a white screen on. And that was the way the standard worked. So the standard, which is now called IEC 61947-1, electronic projection light output, in section 5, which is identical to ANSI, by the way. There's no difference between that standard and what was ANSI, although the ANSI standard no longer exists. It was deprecated almost 10 years ago. So that original projector standard is what people use to do everything. So when they're buying a projector, they say, is this a 3,000 lumen projector, a 6,000 lumen projector? They're looking at that white light output number. We're trying to figure out what we need for a certain size, a certain amount of ambient light. We're using the light output number to make our purchase decision or to make our rental decision. And that light output number works great as long as you have a CRT 3-gun projector or any other type of 3-chip projector. The most important thing to remember is that the current standard actually does work just fine as long as you have a 3-chip projector. So if you have a 3-chip DLP, 3-chip LCOS, 3-chip LCD, all of those projectors, they make light in exactly the same way as that original CRT projector, by having three guns, red, green, and blue, mixing the color together to create white light. So the old standard continues to work as long as you have a 3-chip projector. If you have a 3-chip projector, you have 7,000 lumens, guess what? You have 7,000 color lumens. It's really easy, you don't need to do the second test. But if you have a 1-chip projector, things are different. And by the way, the color space, the important thing to remember is that the color space that we're feeding to our projector, sRGB in most cases, because that's what our designers or Rec 709, our videographers, that's what they're working in. They're almost identical color spaces. But even modern color spaces like P3 or 2020, they all also have equal color light output, meaning that red, green, and blue in those color spaces added together creates white. And so that the brightness of red, green, and blue should equal white. And that's the case for all of the input signals that we use going to the projector. So if the projector is designed to actually reproduce what's being sent to it, it needs to also have equal color light output. So light output breaks when we go to 1-chip projectors, and we're going to look at this in a little more detail after this, but to give a brief overview, single-chip projectors use a single light valve, and then they use what we call field sequential color. So the red, green, and blue, instead of all coming into the screen at once, is interrupted. You get a little red, then you get a little green, then you get a little blue. So if we're measuring our white, that still works if we're only using red, green, and blue. But if we start adding other things in that sequence, like white, that allows us to brighten the white, but it doesn't do anything for color. And if in fact you're using the color wheel, it'll make the color even less. So we'll look at that. Why is this important? Well, it's important because color is the information in the signal. Color can tell you lots of things. If you saw this and somebody was trying to talk about the height of the landmass in this particular synthetic radar image, or scientific image, it looks very different if you don't actually have the color light output. What you're seeing in these slides here is just actual, just like we're doing over here, actual projectors side by side in a single photographic shot. It's the same projector receiving the same signal, but we're seeing very different things. Color is important. Colors are impact. We're designing great shows. We're going around, with their stage shows, making beautiful color images, and projectors can't reproduce them if they don't have full color light output. So color is part of our impact. And color can hide things. So if you saw that, you might not even see, and even if you aren't colorblind, you might not even see what is actually in there, because that's what the input signal looked like. And that's what came out of a projector. And again, this is a side-by-side image they actually shot all at once. So color light output is what we created to fix the problem. So almost 50 companies were members of the ICDM that voted this standard in. A lot of work, a lot of research, a lot of testing went into this. We tested almost 50 projectors before the standard was created, specifically to gather data on whether it worked and whether it, and we published that data, and we worked with the different scientists and engineers, all of the different companies that are part of the standard. Visa is part of the ICDM and sponsors the ICDM, so it's also a Visa standard. And the SID, the Society of Information Display, are all the scientists that actually work for all the people around here are members of SID. So that's where this standard came from.